to Code Wars, which is just basically a repository of a number of coding challenges that's like very gamified. So you just sort of like move through ranks, and we have a full stack academy organization. We invite you guys to join it. That way you guys can kind of like compete, and we can see how well you're doing and whatnot. Good question.
So is this internal to full stack academy?
Oh, absolutely not. No, this is like a major enterprise. Not major, but it's codewars.com. It is not a subdomain. But they allow you to organize by organization or teams or what have you. And so there is a full stack academy organization. And you can join that. And that way it gets really fun because then you can see how you're doing and compete against your peers and what have you. And this is just like it's a little big. Problems like this, where you have to do stuff with arrays, string manipulation. Of course, the easier the problems. Initially, they accumulate, and then you get to tackle harder problems and scale up the ranks. And there are notions of things like honors. You get more honors, more problems you tackle. Pretty self-explanatory for the most part. You have these test cases that you have to pass, so it's kind of like a test first. Well, you're not writing the test, but beat the test and you solve the challenge. And we sort of institutionally really support this repository of problems. So once you reach a certain level, we'll like hand out T-shirts, what have you. Gabe, what level is that again?
Sorry?
The level that they have to reach in order to get a prize?
Fourth.
Right, 4th Q. Great, and you start at AQ. So. Like a T-shirt, or we throw a party, I think, at the end of the semester to celebrate all of those who achieve a certain rank. So yeah, I mean, definitely encourage you to get started. I think on your calendars, there's like a 9 to 10 every morning slot for just working on Code Wars. This is the kind of thing where, it's like great to start off the day with it, because it's like doing jumping jacks, but for coding, So you'll have a better rest of the day if you just start out doing one of these problems. There's also exorcism.io, similar thing, not as institutionally supported by us these days, so I would stick with this, but the whole point is just to get you guys flexing your muscles and continue to do basic logic problems as we get into web development. We want you to feel comfortable tackling discrete problems that are just logic heavy and not so much like application oriented. Make sense? Yeah. So actually I think the first step would be to, in LearnDoc, click the link your GitHub button, I think on the settings page. That's like not necessary, but now that I'm thinking of it, do that. And then you can authenticate into Code Wars with GitHub. So you can just log in through a GitHub profile, and then you can find the Full Stack Academy organization on Code Wars and then join that. Awesome. If you have any questions, I can come around and answer those after. But let's just sort of jump into the lecture. I think you guys will be able to figure this part out. Let's see. So this is actually going to be a pretty short lecture. Because the whole point of it is just to introduce you to Game of Life. Any of you folks know what Game of Life is? A board game. No, not exactly. But yeah, we're not talking about that though. What's that? Yeah, it is kind of. I mean, it's on a grid, right? So there is a grid. Anyone else? Any ideas? Andrew, I know you know. Come on, help me out. Help me out. No? Andrew, you gotta say something. Okay. Yes. Okay, so right, Game of Life is a game that it's like a single player game that's essentially an animation. And it started because by this idea some folks had to try to simulate life, okay, by applying a few very simple rules to the evolution of state, essentially. So we're going to get into what all that means in a second. But this is basically what it looks like. You have a grid, right? Just like X, Y axis. And you have these squares, and each square is considered to be like a cell, okay? And a cell can have one of two states. It can either be alive or it can be dead. These colored in cells are alive. The other ones aren't, they're dead. And so you start off by selecting a certain state for the board. So this is our given state, this is the initial state. And based on the application of 4 basic rules, this board will change from state to state to state. And I'll show you a little demo of that. And it's cool because, I mean, it's kind of inspired a little bit of a cult following, because the idea is that as the board evolves, it starts to look like the multiplication of cells, you know, like a little petri dish, which of course like mirrors like human beings on the earth if you zoom out, like take a panoptic perspective, right? So it's like, you know, mimics life in the macro to the micro. So let's get into what that looks like. I think the next is, right, so I just clicked it, now it's evolving. And again, each evolution from one state to the next is governed by the application of 4 rules. That's it, it's very simple, but it looks quite complex. So it's this kind of dynamism, or just really the disjuncture between the simplicity of the rules and the complexity of the board that that Conway got really fired up about. Awesome. You can also just like see that again. Ugh. There we go. So state to state to state. Great. So yeah, how about some more background? So again, it's a 0-player game. It's really just an animation, right? These 4 rules are applied programmatically each time. So it's entirely deterministic, right? And yeah, this sparked a niche field called cellular automation. Again, this idea of simple rules producing complex behavior. So what are those rules? Does anyone know? Yeah, Andrew knows. Okay, well, I'm just gonna act like you don't. So right, we have these this 2-dimensional grid, and at each turn, certain rules are applied based on the state. So if the cell is alive, and if an alive cell has fewer than 2 live neighbors, then it dies due to underpopulation, right? If you're out in the desert, you're probably not gonna make it very long. Only like 1 veteran camp within 50 miles of you, you're not gonna get water, you will die. So that makes sense. Like these are the things that happen in real life. Then if a cell is alive and has more than 3 live neighbors, dies, right? Overcrowding. Which, I mean, really begs the question of like how we exist on this very tiny island. But we do, due to, I guess, like a number of miracles. And then otherwise, if it is alive and it has exactly 2 or 3 live neighbors, it persists, right? Perfect balance. This is what life needs. And then if, so those are the rules as applied to alive cells. And then if you are dead, you can come into existence if you have exactly 3 live neighbors. Exactly 3 live neighbors. Then a dead cell can come to life. Otherwise, you just remain dead. So what do we mean by neighbors? We're talking about like pure adjacency here. So any of these cells touching any part of the cell in question is a neighbor. Each cell has exactly 8 neighbors. So it's based on this application. And of course, this requires us to capture the state of the board at any given time. Not only know which cells are alive and dead, but to know the number of neighbors that each cell has, so that we can correctly kill it in the next round or make it come into existence or remain in the state that it has at the current time. Okay, so this is actually the trickiest part of creating the game, right? Not simply capturing state, but also capturing the state of the neighbors and associating those neighbors to each particular cell. You guys see how it would be impossible to start applying the rules before you've entirely captured the state, right? You turn one cell on, that affects the rules as applied to the other cells. So we have to sort of freeze it, hold it, assess the neighbors, assess the live dead state, and then apply the rules to the entire board to get to the next state. And that's why I really like this workshop, because I think it's a really great way to learn about state and how important that is, and also about ways to model state, which is, of course, is like a very important pursuit, I guess, like, and very persistent one in web application development. So great. So those are our neighbors. So let's like go through a more in-depth simulation. So let me actually pause this for a second. So here we have these 5 alive cells, and the numbers within them indicate the number of neighbors it have, right? So this cell has 2 neighbors, and because these cells, I guess, had too many, or too few rather, this cell in the top corner is dying from underpopulation, only has 1 neighbor, so it's a goner. This also underpopulation, only 1 neighbor. So these are going to be axed, but this one will come alive because this one has 3 neighbors. So this one pops into existence, these 2 die. Right? Make sense? Let's go through the simulation. So this will determine the next state of the board. Cool. So great. Here again, we count up the neighbors, and then apply the rules. 3, 3. This means that these 2 will have to come into existence. Quarter ones die, and so on. Any questions about this at this time? Pretty straightforward, right? Yeah, I mean for now, right? Like wait till you start the workshop, right? It's like, oh yeah, I get it, but how does that actually work? Okay, cool. So we'll just sort of, yeah, sort of go on here. Cool. So state is something I really want you to be thinking about, because that's just the tricky part. There are really no surprises here. There's no point in letting you discover that later. That's the main import of the workshop, is in going through this exercise of figuring out how to capture a model state, how to model the aliveness and the deadness. Great, 2 states that you have to keep in mind, as well as counting up the neighbors and associating those neighbors with these alive and dead cells. That's your task. I encourage you to be creative when coming up with solutions. And then, of course, this is going to require you guys to attach event handlers to the boards and to the cells, right? So you guys feel comfortable doing that? Yes? Okay, so let's like go through some basic event handling. Let's see, so cool. So here we go. We have another simulation here. I'm going to open up console. Okay, cool. So you know how we can grab this document. You guys did this with Selector.js. We can also, of course, grab the body as a property of the document object, and then add an event handler, an on-click. Yes. Oh yeah, this is not big enough, is it? That's too big. Great. You guys see that? Cool. So great. I have this on-click function or method of the body object, and I can sort of attach many things to it, really. I can add an alert if I want to. I can say, I am happy. Yeah, great. And then if I click anywhere on the body, I'm going to get this alert saying I am happy, right? This is using the built-in API here. More importantly, I can use these the built-in functions to do some event delegation. So if I pass this function, this event handler, the event object, I can then see the target of the click event. So let's see what that looks like. This event object has a target property. So I can say, this is the target. Target. And I can click here, and I get the canvas, right? That makes sense. If I scroll down here and I hit step, I get the step button. So that's cool. I mean, this is like a pretty hacky way of going about like selecting the actual target of a click handler, event handler. because I attach it to the entire body, the way I could theoretically leave that handler there, use the event object to grab the actual target, and then have that target do something, apply some functionality to that target or what have you, right? But this is just getting you into the idea of attaching event handlers to objects in our DOM, which is of course something we're going to need. If I'm playing a game, I'm going to want to be able to click on the cells and then hit a run button, what have you. So you'll be doing this throughout. But also, one of the things you'll get into with this workshop is dealing with the this context, right? So let's see. So if I take this click event handler and I remove this for a second, and I say this here, and then I console log the this. Let's see what happens. If I click on one of these cells, I get the body. I click on run, I also get the body. That makes sense, right? Because I attach this click handler to the body. So regardless, that's the this context. It doesn't matter where I'm adding, where I'm clicking. That is going to be the object on which the method is called, which is why it's the execution context for that handler. Your task will often be to figuring out how to get this to point to what you want it to point to, given the handlers. But that's just, again, just to sow the seed for you guys to be thinking about state, this context as well. Those are like your two main, I think, like guiding concepts for this workshop. Making sure this refers to the right object and managing state. Any questions? Yes. Oh, sure. Canvas is basically like I like to think of it as a scrim, you know, like we can apply any number of graphics or animations to it. Yeah, I think that there's like a pretty good explanation of that in the workshop. But I like to think of it really just like as a backdrop. And for painting, for applying colors, it's just like a pretty easy, it's really just like a more minor DOM or like a sub DOM. I like to think of it as nothing too special. I mean, yeah, as far as I know. Yeah. Any other questions? Great. I'm going to open up this workshop. You guys, again, lunch starts at around 12:50. Never feel the need to work through it. Definitely make sure you get your rest and your food. And I guess we'll be continuing with this workshop through the afternoon. Okay. All right. So I'm going to open it and then Slack out pairs in the next couple of minutes.